today, this is the talk. So it's preparing Apache Kafka for Scala 3. You might have joined, maybe if you were awake at that point in time, a talk from Nathan Silnitsky about migrating a Scala library to Scala 3. That is a wildly different story in this particular case. So if you've seen that one, this is another take on, completely different take of the previous one. I want to ask a question to the audience. If you did that, please react with some emoji or something. Anybody migrated any library to Scala 3? Okay, some hands, more than what I would even expect. That's great. So today I want to explain a story in 3 different acts. So first I want to set the stage and explain why I am here. So it starts with the origin. Every story should start with an origin. I will go into the thing, the meat of that talk, which is the challenges that we faced during this proof of concept that we did, trying to migrate Kafka to Scala 3. And in the end, I will try to explain and give my point of view on what we should improve as a community to make things better. Let's start with the origin. So I want to make 3 things clear for you: who, why, and what. Who, it's that person over here. You might have seen me if you were on the quiet corner of the ACA communities. That one that, we are the ones quiet most of the times in many conferences, and the ones that will not make that much noise on Twitter. I was over there. I was doing things in Apache, in ACA GDP, and now I'm working at Ivan, and I am the manager of the open source program office, which is pretty cool. So why I'm here? So this is who I am, but basically why I'm here. So Ivan offers managed open source data infrastructure as a service. And among those services, there is Apache Kafka. You could have guessed that one, I guess. Flink, Postgres, OpenSearch, and many others like MySQL, for example, M3, Cassandra, you name them. We have a lot of those ones. And the open source program office, basically what it does is it employs people to work on those open source projects. So that's why I'm here. So I was working on Apache Kafka. And in case you don't know what Apache Kafka is, just let me put these 2 small slides. This one, probably you know everything, but anyway, let me put it. It's a distributed event streaming platform. It's extremely scalable. It has high throughput, and it has high availability. So that should be no news for any of you. This other one, though, unless you are looking at the code base of Kafka and you're really coding inside Kafka, you mightn't know some of those details. So let me explain them to you. That's the code distribution, the language distribution on Kafka. I took those numbers from GitHub widget that you can see on the main page. So you can see Kafka has 23% of code written in Scala and a huge amount of Java code, which goes up to 74% of Java. So we were chatting just a moment ago with Mark about, I needed to go check Kafka, and almost always I was ending up on the Java side of it. That's one of the reasons. So 73.9% of the code is Java. So it's easy to fall in there. So some facts of the Scala part of it. So it compiles in Scala 2.12 and 2.13. So you might think we are quite good to start with. So it's not that bad. It uses Gradle as a build tool. I maybe can see some frowny faces at this point in time, but well, it is what it is. Kafka core is mostly written in Scala, and the 23% of Scala code you see there is mostly on that module. So it sounded something contained. And again, there was no macros nor type classes. So that also meant that everything was kind of set to a nice thing. So it seems like a walk in the park. As I was mentioning before, before the talk started, I was thinking that should be a nice return of time invested. So I will spend some time in here and I will be able to migrate Apache Kafka to Scala 3. That sounds awesome. No, I was wrong. So that goes to the next part of the talk, which is challenges that we face during the proof of concept. The first challenge was regarding Gradle. If you were to Nathan talk this morning, he was mentioning, oh yeah, Gradle now supports Scala 7.3. So when I started this migration attempt, that was summer 2021. And Gradle wasn't supporting Scala 3. It was only Scala 2.12 and 2.13. But first I didn't know that. So I thought, okay, how complicated could it be? I just probably just need to change dependencies Gradle file. I might need to change the build Gradle file. I might need to do some magic with version names. I mean, of course, we know that SBT, you can do the double percentages and it does lots of nice magic for you. Gradle doesn't do that. So I probably need to do some tweaks there. Some libraries change the name and they have a prefix or a suffix with Scala 3. So I needed to do probably some magic over there. And then I could profit. And I could basically compile Kafka with Scala 3. And I tried that. I really tried that. That's the PR where I tried this thing. And I failed. So it wasn't working. In the end, it was compiling with the Scala 2.12 compiler, or even 2.11. I don't remember. So it was really like not working at all. I went to Gitter, that now the defunct Gitter channel for the Scala contributors, and Scala Center as well. And I asked, hey, is there any intention to work on Gradle support for Scala 3? And luckily, and I'm really happy, Tomasz Gottschik, sorry if I pronounced the name not correctly, was there and said, that's something we should probably work on. And he single-handedly introduced support for Scala 3. So if you see him, just buy him a beer if he wants that, or do whatever. I mean, huge kudos to him. If you see him, just exactly, that's the thing. That's what I want to see. That's great. So thanks to him, we have that thing. So if we can use Scala 3, it's because of him. And that's the status of the issue. You can see the issue over there, and it's from version 7.3.0. That's great. So I had one thing done, so I could just continue and try my endless journey towards migrating to Scala 3. So let's see. I started, now I could compile with Scala 3. So now I could find problems on the Scala codebase of Apache Kafka. And then it's when I started to find the weird things. So there be dragons, and there were dragons, and strange dragons. The titles that you would see as introduction of the issues that I found, they become weirder and weirder because the issues were weirder and weirder. So the first thing that happened that I found was the unit SAM, so single abstract methods, and overloads. So let me explain it with an example. So that's more or less not exactly the code that it's in Kafka. It's a simplified reproducer, but it's exactly, the essence is exactly the same thing. So given a class with 3 methods that they are basically overloaded, and this one is called asset throws, and they contain a class, which is what you see, not really magic in there, and they contain an executable. An executable is a Java interface that basically takes nothing and returns unit. Really type safe for Scala people, but hey, that's Java. I mean, that's one of the problems. We in Apache Kafka, we deal a lot with Java. So yes, you can laugh. I mean, I was laughing in the beginning, and I ended up crying because of those problems. So yeah, you have this one. You have an overloaded method which takes the same thing with an extra parameter, which is a string. And then finally, you can see that there is an extra asset throws, exactly as the before, but it doesn't take a string, it takes a supplier of a string, which again is, I take nothing and I return a string. So far, so good. If you think like, should it be any problem in there? Probably you wouldn't guess that should be no problem. That seems like a pretty straightforward code, right? So that should work. And yes, sometimes it works. So if we call it this way, so asset throws and with a class of illegal argument exception, and I create some random function that returns a 3. So because again, what I'm doing here, that's a testing tool. And what I want to do here is like, I want to do some business model method that I want to try that might return things or might not return things. The testing library doesn't really care. In this particular case, I create a function that returns a 3. And that works, that compiles. No problem so far. Here comes the problem. Whenever we need to define the overloads, it cannot find the right one. Because in here, we need to match against a class of, so cool, that we have. We need to find the third parameter is a string, that we have. But the middle one, it's again, suddenly it's not that easy because it's not a it's not an executor. Suddenly that one is a supplier, and it doesn't know how to translate these two things. And that one doesn't compile in Scala 3.0. It compiles in 2.12 and in 2.13, but not in 3.0. And you might say, well, that's only maybe because of the string at the end. I don't know, maybe, let's see. No, even if we use the function supplier for the string, it also doesn't compile. It doesn't compile. And I was puzzled. Then I said, okay, is there a workaround? Yes, there is a workaround. And actually, it's really funny. I need to just make sure that the compiler understands that the middle function in there is an executor. So I need to force a unit return. Yay. And now that's how my Scala code looks like. Yes, exactly. That's my feeling. That was exactly my feeling. Those funny faces and crying. I mean, I was more crying than laughing. But yeah, it's more or less the same thing. Yes. In here, you can see that one works. It's fine. You don't need to change anything. On the second one, yes, I need to change the return type to force it to be a unit. The same thing in here. So I create an issue. It's that one. You can go there. You can check that. You can see the discussion. Unfortunately, that's not solved, and it won't be solved. It's closed as one fix. And right now, the explanation of why it won't be fixed is because it conflicts with existing Scala 3 code, making functional code right now fail. You can go to the issue, you can see the discussion. There is even a thread on the other one where you can see that one. Probably there are other workarounds to basically overcome that issue, but the issue itself stays. So that was one down. I have a workaround. I can live with it. I can just make my code not so nice on Scala, but I can continue. I can do that thing. I can live with that. However, then I found the non-static forwarder methods in Trait Companion, and it's Trait Companion. So you might know this pattern. You have a object, which is called object trait pair, which has basically a val constant. So it's just to do the Java-like thing of putting all the constants in the object companion as well to do the kind of the static fields on the objects. Again, remember that the code that we write in Kafka needs to be accessible for Java code. That's the setup. That's the tone of the things we're doing here. And we have a trait companion class. It needs to be a trait. And it has whatever. It has a method called that's called method, or a val, sorry, that's called method that returns a string that it's hard-coded to by. Doesn't matter. It's basically, the problem comes here. In Scala 2.13, this class bytecode will carry over any val and any def defined on the object, and the companion object. But that doesn't happen in Scala 3. So if I do the job up of this object trait par class, that's what you get. You would get the public interface of object trait par, and you have the three methods, the init one, the string method, and then another one, which is the setter method. However, it should be this thing here, and you can see that there is one method missing. What that means is that any Java code trying to reach that static method that was until Scala 2.12 and 2.13 forwarded, and it could be accessed directly with object trait pair dot constant, it's not available anymore. And it needs to be reached again with the nice fancy syntax of dot, so object trait pair dollar dot module dollar and then constant. So that's another one. That one's fixed. So that one is fixed in Scala version 3.10. That's the Dotty issue, and it's fixed. By the way, all the links in here, basically that's a website. All those links will be shared at the end. There is a QR code where you can access this presentation. Let's go to another problem there. So variable handling in supercalls. Again, the names are getting stranger the more I go down. So given this class here, which, let me just go back. So we have a class with a lambda, which is basically a normal class that takes as a constructor, and the constructor takes a method that, an argument that takes nothing and produces a long. So it's a supplier in that sense. And I want to extend this class with just having a var as a parameter that extends this class. And I just basically put something on that lambda that I want to put in there. That thing compiles. However, it throws a runtime. And you can see that that's a problem. I mean, I could only see this problem when I was running the tests, not when it was compiling. So again, we use Scala to avoid those things, right? So we want to have like, okay, it compiles. So we want to say it compiles, ship it. So no, it doesn't work. In this case, it was failing at runtime. However, now let's see the workaround, and we might try to guess what the problem was. So we have the same class with Lambda. It's still the same supplier. It takes nothing and returns a long. But now, instead of putting a var on the parameter that then will force the creation of the getter and the setter, I just put whatever name there. It's not a var, so it's just basically gone. And then I define the var message afterwards. That works. And yes, that was an issue. It was filled. It's fixed in Scala 3.1.1, and it's available for everyone. So basically in here, there was a problem again on the initialization. So again, I didn't solve all those problems. I don't take credit for solving any of those ones. I was just reporting them. But yeah, the Scala team was great and awesome, listening to my runs on saying, I found something strange, and trying to find the producer, and then they were listening to me, funnily enough, and we found the solutions. Then another strange one, handle Java var args with parameterized T. So as I said, it's getting stranger by the time. So given that class over there, it basically it's a type var args class, which just has a method var args, which takes a thing of type v, and then it takes a var arg of v things. So in the end, it means that I can call var args with one thing of the type v, or as many as I want, but always one is the minimum one. So I always need to put at least one thing. And if I have this Scala code down there, where I instantiate that that class, and then I try to call that method, that compiled, but it throws at runtime again. So my friend runtime was attacking again, and I could, again, only see these things on runtime. And that was really strange. And again, to find the reproducer for this one took me quite some time. So in here, you can see that what I'm doing is instantiating it with one long. So I'm trying to say it's a long thing, please use that long. And it fails. So the workaround is, let's go back for a second. What I was doing here is I was using Scala long, but if I use Java long, then it works. And that compiles and that runs. So again, that was hinting me probably that there was a problem with boxing, and not the boxing with gloves, but the boxing and auto-boxing in Java. Good luck though. Also an issue, also filled, also fixed, and it's available in 3.1.1. Last one I found. It doesn't mean that maybe there are other hidden somewhere else, and maybe there are other more niche and subtle problems around there, but that was the last one that I found that it avoided me to compile Kafka in Scala 3. Type erased for by name parameters. I was having trouble to define the issue itself. So in this particular case, we have the object by name param, which only has a method that's called by name param, which takes you guessed that, a by name param. No, I mean, nothing wrong here. It sounds really trivial. And that one is not complex to understand what happened. What's really strange is that it happened. That's the output of the bytecode. If you see what it is, it's basically a by name param of Scala function 0, and it lost every type there. It's just a function 0, when it should be a function 0 of string. So somehow in the compilation process of that apparently simple code, we forgot something. So that's release. I mean, does anybody know if 3.1.2 is released already, or it's still on release candidates? I guess it's still in release candidates. So it's a pre-release. Yeah, it's a pre-release. It's almost there. It's in 3.1.2, release candidate 1. So it will be there eventually. And again, that's again the Dotty issue and the one how it was solved. A summary of everything I shared of the things that happened on my journey that in theory was just a walk in the park. That's what happened, the status of the issues, and since when it's available, if it's available. Easy. Huh? That was easy. That was nothing, no problem. It's completely worth my time. So, last part of the journey. So, what should we improve? That was the hardcore part of the talk, let's say, and probably funny. Now it's for the serious part of the talk. One thing that I want to make a reflection, and I know that might be probably the conference where it might hurt the most, is it fading away in a sense? That graph here is the evolution of Scala and Java code in Kafka. So if we see the red line is Scala and the blue line is Java, and the vertical axis is lines of code and the horizontal one is versions. So we can see that Scala started with more than 50% of the code base was Scala. And actually the build tool was SBT. I did CLOC, basically run the code lines of code, like count lines of code for every single version that you can see there. And this is the evolution that we see. It's growing on Scala, more or less. I mean, some dips, ups and downs, but it's steadily, it's quite flat growing. It's more or less on the 200,000 lines of code. Goes slightly up, so stable, growing, but really small pace. But Java is going up. So that basically means that every single new feature in Kafka is mostly written in Java. That's something, that's some food for thought. Yeah, Java wins in lines of code as well. Yes, I can tell you that it wins also in classes, and it wins also in modules, and it wins in every single thing you want to compare. But yeah, fair point. Java will almost win in lines of code. But it's fairly fair to say that now Scala is contained only on the core of Kafka, and everything surrounding Kafka is Java. So another thing that probably we as a community, a Scala community, can probably think about and try to see how we can improve this thing in the future is we've seen the story from Nathan before, like how complicated it is to migrate from Scala 2.12 to 13 to 3 from Scala library code. And it was pretty much straightforward as long as you don't use deprecated features. So Kafka doesn't use any of those deprecated features. However, it was pretty much not possible to do. We needed to modify the language. We need to modify the compiler in several places to be able to have this change, to be able to migrate. And basically, one of the problems, and I guess Seth is here and he can confirm that thing, which is Java and Scala interoperability improved a lot between 2.12 and 2.13. But Dotty kind of was developed in parallel, branching out on 2.11. So some of the improvements that happened in 2.12 and 2.13 were backported to Dotty, but some of them were kind of maybe forgotten, maybe not really ported, maybe the test suite was not completely pushed, or basically was mimicking the same things on both sides. And that meant that some features and some Java Scala interop was lost. And those ones are basically all the things that I found on this talk is Java Scala interop. The community build. We had this chat also in Gitter at one point in time. So we need probably more non-fully Scala-friendly environment. What I mean by that, so right now, the community build, for the ones who don't know that, it's basically the build that runs against every single build of Scala to make sure that nothing breaks the Scala ecosystem. And right now, most of the projects in there are Scala ones, purely Scala ones, or almost only Scala ones. And as far as I understand, they only can run in the community build if they are SBT projects. Kafka, for example, it's not an SBT project, and it will not be an SBT project ever, or again. So probably we need to make sure that we can include those projects that use that use Scala in the wild, and probably they are not the most Scala-like ways of writing, and they will use all the different kind of build tools. They will be using different styles, and probably we should do efforts to incorporate those projects into the build to find those problems earlier. And then probably including those projects in the fringe of the core of the Scala community would be great. So right now we put projects that the core people in Scala maintain, and we put those there, and we make sure that those ones always compile with the latest version of Scala. So probably we need to do an extra effort and take some of the projects that are far away from us as a core Scala community. And I want to have a word about these mixed Java Scala projects. And basically, probably those mixed Java Scala projects coming to the Scala community might not happen. So maybe we should go to them. Maybe we should try to be closer to those ones, offer our help, offer our support on those projects, and try to help on the Scala part of these projects. And that's my call to action for today. It's basically buy local. So in that case, it's go to your local Java Scala open source project and help. Further info in here, you have a mailing list thread where all this thing was discussed, the proof of concept, the in-between step that I did, the blog post, and this is a QR code where that's a website on GitHub. You can just scan this QR code. These is the slides. You can just go and click every single link that was appearing here. And I just want to say thank you a lot for attending this talk. And hopefully I inspired some of you to be closer to those communities. Thank you very much.